Alternators are devices that convert mechanical energy into electrical energy through the process of electromagnetic induction. They are commonly used in vehicles to charge the battery and power the electrical system. Here's a detailed explanation of how AC current from an alternator works and the process it goes through before charging the battery. Rotor and stator. The alternator consists of two main components, the rotor and the stator. The rotor is the rotating part of the alternator, usually driven by a belt connected to the engine's crankshaft. The stator is the stationary part surrounding the rotor. Electromagnetic induction. As the rotor spins inside the stator, it generates a changing magnetic field. This changing magnetic field induces an alternating current, AC, in the windings of the stator. The AC produced in the stator windings is in the form of a three-phase alternating current. Rectification. The alternating current produced by the alternator is not suitable for charging a battery or powering most electrical systems, which require direct current, DC. Therefore, the AC output of the alternator is passed through a set of diodes arranged in a configuration called a rectifier. The rectifier converts the AC into DC by allowing current to flow in only one direction. Voltage regulation. The voltage produced by the alternator can vary depending on the speed of the engine and the electrical load. To ensure a consistent voltage output, alternators are equipped with voltage regulators. The voltage regulator monitors the electrical system voltage and adjusts the field current supplied to the rotor to maintain a stable output voltage. Charging the battery. Once the AC current is rectified into DC and regulated to the appropriate voltage, it is sent to the battery for charging. The battery acts as a reservoir of electrical energy for the vehicle's electrical system and provides power during startup and when the engine is not running. Now, regarding the brushes in the alternator. Brushes are crucial components in an alternator that facilitate the transfer of electrical power between the stationary and rotating parts of the alternator. They are typically made of carbon and are mounted on the stationary part of the alternator, called the brush holder. The brushes are held against slip rings attached to the rotor shaft. Function of brushes. As the rotor spins, the brushes make contact with the slip rings, allowing electrical current to flow from the rotor windings to the external electrical circuit. The brushes maintain constant contact with the slip rings, ensuring a continuous flow of electricity. They also transfer the voltage regulator's control signals to the rotor windings to adjust the magnetic field strength and regulate the alternator output voltage. Wear and maintenance. Since the brushes are in constant contact with the slip rings and experience friction during operation, they can wear out over time. Regular inspection and maintenance of the brushes are essential to ensure optimal performance and longevity of the alternator. Brushes are designed to be replaceable, and periodic replacement is necessary to prevent electrical issues and potential alternator failure. In summary, alternators generate AC current through electromagnetic induction, which is then rectified into DC, regulated, and used to charge the battery and power the electrical system of the vehicle. Brushes play a crucial role in facilitating the transfer of electrical power between the stationary and rotating parts of the alternator. Now let me explain the key components. An alternator is a complex electromechanical device composed of several key components, each playing a vital role in its operation. Here's a comprehensive list of the main parts of an alternator and how they work. Rotor. The rotor is the rotating component of the alternator. It consists of a shaft and a set of windings or coils. The rotor rotates within the stator and generates a changing magnetic field when an electrical current is passed through its windings. Stator. The stator is the stationary part of the alternator. It surrounds the rotor and consists of a set of stationary wire coils. When the rotor rotates, it induces an alternating current, AC, in the stator windings through electromagnetic induction. Diodes. Alternators use diodes to convert the AC produced by the stator into direct current, DC. Diodes are electronic components that allow current to flow in only one direction. They are arranged in a configuration called a rectifier bridge or rectifier assembly. Rectifier assembly. The rectifier assembly is a collection of diodes arranged in a specific configuration to rectify the AC output of the alternator into DC. It ensures that the electrical current flows in one direction, which is necessary for charging the battery and powering the vehicle's electrical system. Voltage regulator. The voltage regulator is a control device that regulates the output voltage of the alternator to ensure a consistent voltage supply to the electrical system. It monitors the electrical system voltage and adjusts the current supplied to the rotor windings to maintain a stable output voltage. Brushes and slip rings. Brushes are conductive components made of carbon that maintain electrical contact with the slip rings mounted on the rotor shaft. They transfer electrical power between the stationary and rotating parts of the alternator. The slip rings provide a rotating connection for the brushes to transfer the current from the rotor windings to the external circuit. Bearings. Bearings support the rotor shaft and allow it to rotate smoothly within the stator. They reduce friction and wear between moving parts, ensuring the efficient operation and longevity of the alternator. Cooling system. Alternators often incorporate a cooling system, such as a fan or ventilation openings, to dissipate heat generated during operation. Cooling is essential to prevent overheating and maintain the optimal operating temperature of the alternator components. Housing. The alternator's housing encloses and protects its internal components. It is typically made of aluminum or other durable materials and provides structural support for the alternator assembly. Pulleys and belts. In automotive applications, alternators are often driven by a belt connected to the engine's crankshaft via a pulley system. The rotation of the engine drives the alternator rotor, generating electrical power. These components work together harmoniously to convert mechanical energy into electrical energy, regulate the output voltage, and charge the battery while powering the vehicle's electrical system. Rectifiers, integral to modern electronics, are the unsung heroes that bridge the gap between the alternating current AC, supplied by electrical grids, and the direct current DC vital for powering an array of devices. Through a clever arrangement of diodes within rectifier circuits, these components seamlessly convert the oscillating AC wave into a steady flow of DC power. This process is pivotal for a plethora of electronic gadgets, from the smallest cell phones and laptops to larger household essentials like televisions and radios. But their utility extends far beyond homes. Rectifiers power the machinery in factories, ensuring smooth operation in industrial processes. They serve as electrical gatekeepers, permitting current flow in only one direction, thereby rectifying the alternating current into a unidirectional stream suitable for the intricate workings of electronic systems. In essence, rectifiers are the silent enablers of our connected world, quietly ensuring that power flows reliably to every corner of our modern lives.